Hey everyone, this is That Programming Guy, and remember, you can do the thing no matter what you're doing, no matter what's going on, no matter how big of the thing you're doing. I believe you can get to do it, and remember, you can do the thing. And speaking of remember, you can do the thing. I know I've been saying this in my YouTube videos for a while, and I know I said it last week, the week before last, the week before that, the week before that. Well, finally my shirts are in and I have one to show you, and I'm very happy because it's the best shirt in the world. Here's what it looks like. Are you guys ready? Hell yeah. We got a nice rainbow, a nice fugly unicorn, me with the controller and a laptop, and words that says, remember, you can do the thing. It is the best shirt. I'm wearing a medium currently. I do offer these in both white and black. I have not really experimented with any other colors, mostly just because I haven't, but red and black seem to work. Black and white seem to work right now. If you would like one of these fucking wonderful shirts, just contact me. If you're on YouTube, contact me on YouTube. Contact me on Twitter. Contact me on Twitch. There's many ways to get a hold of me. Many ways to get a hold of me. So, Benjamin Franklin's Gout, thank you so very much for the follow. I appreciate you. You are appreciated. What else is new? So I'm going to try to be, instead of recording these offline and posting them online, I'm going to try to do a stream and then release them. So that's what I'm going to try to be doing. We'll see how that works. The idea is to stream every Saturday at 11:30. I would like to stream more. The only problem is my mornings are filled up with things like chores and shit. I wouldn't mind doing more streaming, actually. That would be really fun, but, I've active Fireball from 8:30 in the morning to 9:30 in the morning, and then I walk my dog, and then I leave for work. So the only way I could do things in the morning would be to wake up earlier. And I actually tried doing that, but I'm really bad at waking up early, in case you haven't noticed. So anyway, just making sure that's going. So where are we today? Last week, I was going over, I think, decomposition. I believe. I don't remember. I'm not going to look it up right now. I know I did before I started. I'm not going to look it up right now because there's stuff I don't want you to see on my computer. But yeah, also, if you notice, we have the fancy camera, I think up in that corner. It's facing down on my notebook, and this is for me, and this is so I can write because writing is, for me at least, is much more helpful. Is much more helpful than trying to figure things out in my head. And I wanted to write before, but since you guys couldn't see my notebook at all, there was no point. So now you can see my notebook, about a second camera, you guys can see that, which is great. So now I'm probably going to write this more. In fact, actually, my 68K programming videos, you can see I'm making quite good use of this second camera with the notebook. So after the previous video, or the previous video, newmaidumosa, bless your soul by the way, made 3 gists. Is it gists or gists? He's like, I see what you're doing, let me help you and make it more Haskell like. So I read some of it, I don't know, a few days, like 3 or 4 weeks ago. But I'm like, you know what? No, now that I have this notebook, let's make it part of the series, So what we're going to be doing today, and probably in for 2 or 3 or 4 more videos, is we are going to go through the gists. There's 3 that he made. One with lists, with just a global variable. One with passing the configuration object between functions, and one is using the reader monad. So we're going to start off the simplest one. So he took what I was doing, and he basically made it better. Made it more Haskell-like. Because I've been getting things done with Haskell. But, phew, I've been getting things done with Haskell, but I haven't written in the most Haskell-oriented fashion. So, are you ready to start? Because I am. And we will do this together. Also, maybe tonight, for the people who are watching, I might do another stream with a person named Asmodan to help him learn Python, and that would be cool. Alright, so let's go over newmaidumosa's thingamabobber. And let's get this blinky thing out of the way. Alright, so the prototype of the maze build would actually use mutable vectors because lists are way slow for update. That's fine. The next version will use mutable vectors. So the maze is built by creating a list of cells and going through and randomly removing one of the walls of the cell. This obviously leads to closed loops and sections completely walled off, but this is, look at the syntax, not about the algorithm. Makes sense. We have the configuration of our maze in global variables. But it would be better to have this in some sort of configuration data type that can be built from IO input and then passed to the functions. I will have a look how to do this. These are ways to actually manually pass the configuration along to each function, but this is clunky, and the better way is to use a reader monad. It is a bit contrived here, but I'll write versions of both just so we can see how it works. What is a thing? A monad. Computations which read values from a shared environment. Oh, that's cool. Monad values are functions from the environment to a value. The bind function is applied to the bound value and both have access to the shared environment. Well, I didn't know there was a thing that could do that. Ask local, the function to modify the environment. Reader to run. Oh, I get it. That's really cool. I didn't know something like this existed. That's awesome. Okay. I'll have some extra comment, yeah. So basically import data.list.split into chunks of. Okay, what are chunks of? Contains a wide range of strategies for splitting lists with respect to some sort of delimiter, mostly implemented through a unified combinator interface. The goal is getting started. So, you know, if you could just tell me data chunk of. To get started, you should take a look at the chunk of splits the list into length and pieces. Okay, that's fine. So this random IO. Yeah, I know it's not the strongest random library. A lot of people say if you want actually like cryptographically, whatever, if you need really fucking scary random numbers, random IO is not the way to do it, which I know. But considering we're not trying to protect anything with this, random IO is fine. Control.monad, 4M, filter M, fold M. What's 4M? Traversable, a loop then? Takes a traversable on A, so like a list, and a function that takes A to monad of B and returns the monad of traversable B's. Base control. 4M is map M with arguments flipped. For a version that ignores the results, see 4M. What's map M? It takes a function that takes A and returns a monad of B, and takes traversable on A and returns a monad. Okay. Map each element of a structure to a monadic action. Evaluate these actions from left to right and collect the results. Okay. Oh, map M, because M stands for monad. Oh, I'm a dumbass. By the way, I'm constantly looking over here just because I have my laptop here and that actually has my chat on it. If you send me a chat message right now, I actually can't see it. So, that's why I keep looking over there. Alright. Filter M, fold M. Makes sense. Basically, for filter and fold. Control a lens. So, oh, he actually has it right here. That's cool. Oh my god. So, and is flip dot tilde set percent sign tilde apply function. IX is the getter at index. Man, I'm so happy to have this skate. Guys, I'll be right back. I'm going to get some more water. Be right back, I promise. Buy my shirts. Shit. Go away. Sorry, almost tripped and died from this camera's box. Oh well. What? Alright. So. Alright, so lens. I have a bone to pick with everybody about lens. Okay? People who love Haskell need to not write tutorials on Haskell. Do you know why? The best answer I could find. So the reason why is because a lot of people love to over-explain Haskell. They love the theory of Haskell, which is fine. You know, being like, I love Haskell theory, like chiroptical. You know, he's always like, I mean, he has a degree in fucking theoretical chemistry, which just sounds freaking cool. Chiroptical, if you're watching this on YouTube, your degree sounds like awesome. So he loves the theory of Haskell, right? And so I guess you can see when my Discord messages pop up, huh? Should probably fix that now that I'm streaming. Well, not for now. So when I am hold on. That's fine. I'm streaming right now. I know you can see it, guys. Whatever, I don't care. So if I go like this, right? Haskell. What is a lens, right? First 3, 4, 5, 6 answers, right? What is a lens? Lens is a package which provides type synonym lens, which is one of the few implementations of a concept of lenses or functional references. Lens also provides a number of generalizations of lenses, including prisms, traversals, isos, and folds. I'm like, okay, that doesn't say what a lens is. Why would I use it? Why would I care? It is right here. And then, so there's a what is a lens, and then it's like, okay, what is a lens? Guys. If you have to have a second question that is, okay, well, what is this, even though you just answered it, your answer is not correct. Go, what is a lens? And answer it first. So this a lens is a first-class reference to a subpart of some data type. For instance, we have one, which is the lens that focuses on. I mean, I get it. So much stuff, right? I don't need to know that. The lens tutorial targets Haskell beginners and assumes only basic familiarity with Haskell. By the end of the tutorial, you should understand blah, blah, blah. Motivation. And so the closest thing I got was a lens as a first-class getter and setter. Everything else is like, there's so much stuff involved. Like, I don't need to know this. Oh, hey, right here. Lenses are a way to easily access record fields. This is the only answer that's needed. Everywhere should have this answer, because that's what it is. Easy record fields. Pretty cool. That's all we need. So, anyway. Now that we're there, He builds the maze, and he is that. Simply wrapping our maze in a maze constructor because this will allow us to write classes for it, etc. So if we have maze... By the way, I started adding this little cross to the Z, and the reason why I kept doing those was in Calculus 3, that's when you really start dealing with 3D space. And when you're dealing with 3D space, you have X, Y, and Z. And because you have Z, the Z can look like a 2, and that is really confusing. So we have bracket $. Should also figure out what lenses are. Right? Because it's in brackets, which means it's something different. I mean, I had up 2 viewers for a little bit. That was nice. Do you have what everything is? Like, I would like for you to tell me. Like, what is the bracket $? I know newmaidumosa told me that, but I forgot. This one? Will you? Okay, fine. Control find $. Of course not. That's fine. Oh, ampersand. Yeah, no, $. Whoa, what? Oh. Asmodan, thanks for the follow. You're great. Aha, what does that mean in Haskell? Google is... I don't care about Google. Functor, it's merely an infix. Oh, okay, this is fmap. I remember this. $ equals fmap. Wonderful. Asmodan! That's fine. Asmodan, I really haven't advertised that programming guy streaming channel that much. And the reason why is I'm trying to figure out when to stream. Because I'm more active in the mornings. So that's why I do Active Fireball in the mornings usually. But then I need that programming guy. And I used to do it every Saturday. Or at the beginning of the month, I'd record all the month's episodes and then release them on a schedule on YouTube. Which is fine. But now I'm streaming and I want to do it more regularly. So that means I need to figure out something more regularly. So I think I'm going to stream from 11:30 to 12:30 every Saturday to start. But I do need to figure out times how to stream more often. So that's going to be the hard part. So I'm going to try to do 11:30 to 12:30 every Saturday and start advertising that. Yeah, once I'm done with this stream... Oh, Asmodan, I have something to show you. Take a look at this. Take a look at that. It's the shirt. It's the best fucking shirt in the world. It is awesome. And I love it. And you should buy one. If you want. You don't have to. I do know you have a kid. And I do know kids cost a lot of money. Anyway. So... that is fmap. So he's mapping fill maze L onto a maze. All right. You are broke. I'm sorry. That's fine. The shirts will still be here. Speaking of that, I actually am also going to add an extension to my stream. This is just generally for everybody watching, where you can buy the shirts. Because there is Teespring, but Teespring doesn't offer the shirt quality that I want. So I'm making my own extension, which is just a nightmare, actually. Oh, I don't doubt it. I know kids are expensive. They're expensive and they take time. Oh my god, like since Tierney's in bed rest, basically, I have to get her food. If she wants to take a shower, I have to help with the shower. I have to spend time with her. Like, I know that's not bad. I like spending time with my wife, but it's a lot because she has nothing to do. Well, I know kids are expensive, but yeah. Simple Rapper Maze. So what is Phil Maze L? Oh, and here's the maze. And so a maze is a cell list deriving show. You show maze where show maze M render maze. Oh no. No. Bed rest doesn't mean she's expecting. It means she's recovering from a hospital visit of ulcerative colitis flare up. We don't plan to have kids. Kids are expensive. And they take your time. Render maze, render row, render cell, fresh cell, update L, modify L, move to index, from index, valid moves. Where is the nav? Oh my god. Fill maze. Returns an IO of a cell list. Generate a list of blank cells that generate a list of possible neighbors based on index, then update each cell with given neighbor. So so basically an IO is cell list. What's a cell list? A cell list is a list of cells. Probably could have thought of that faster. Fill maze L. Let L equals replicate number of cells in fresh cell. Create a list of blank cells. Oh, this is do. Traverse. Borders from 0 to number of cells minus 1. Get all of them. Pure, I think puts into a monad. Swarm Collective, thank you so much for the follow. Sometimes near the end of a pregnancy, doctors say they have to be on bed rest, so I see. Makes sense. Fold L. Oh my god, why Haskell? Fuck you. Alright, so let's break Fill Maze down, shall we? So replicate basically puts fresh cells into number of cells and puts that into a list. I believe so. Replicate Haskell. I mean, I guess I could do this as well. Stack GHCI. Let that start up. Replicate creates a list. Yeah, exactly. So int an A and a list of A. So if you go back to here, replicate takes the number of cells that you want, which is the width times the height. So in this case, 25. And gets a fresh cell and puts it into a list. And a fresh cell is a blank cell, which is create a cell. So basically, L, Fillmates L basically makes a list of fresh cells. Traverse, oh my god. Traverse in applicative F, traversable T takes a function that takes an A and returns a applicative of B, and takes a traverse on A and returns a applicative on T of B. Okay. though. I mean, English descriptions would be nice as well. You know that, right? Like, I wish GHCI would also give us, like, English descriptions that tell us exactly what the fuck's happening. Like, I get it. I think the idea is by looking at the function prototype to understand what's happening. Class of data structures that can be traversed from left to right performing an action on an element. Yeah, so list is traversable. What is traverse? Map each element of a structure to an action, evaluate those actions from left to right, and collect the results. For a version that ignores the results, see traverse underscore. Okay. And you return F on T of B. So traverse borders. Get a list. Oh, this is get a list of directions, which is impure. Why A? Oh, is this because on IO? It's like, why don't... Okay. So my first question is, why A here? Why don't you do let A? Oh, because you're using bind? Yeah, you're using bind. Okay. You're binding the results. Okay. That's cool. Traverse borders. Borders takes an index and returns an IO of direction. Return a constrained legal direction of a given index because we want the top row to always have east neighbors. Yeah, it's exactly. So basically, to let you guys know, because we're doing the binary algorithm, if we have a maze that... Can you see this? Yeah, you can. Okay. Because we have a maze of, let's just say that... Oh boy, this is bad. I'm bad at drawing, guys. I just want to let you know that. I'm really bad at drawing. Which is fine. So basically, if we can either get rid of this wall or this wall, and if we're in this room right here, we have to get rid of this wall, because if we get this wall, then we have an illegal maze. So, and then if we're on this room right here, we have to remove this wall, because if we remove this wall, well, then we have an illegal maze. So this is just to make sure that everything's legal. And also I used to do 30 minutes. I don't think 30 minutes is enough. I think we'll do an hour. Because it takes me like 15 minutes to get into it. So, otherwise, get choice. Where R and C equals from index I. Row and column. Oh, that's cool. Alright, so in this case... borders takes an index and turns in a direction, which is what we did here. So basically we have an index from 0 to number of cells -1, so 0 to 24. Let's turn this over. 0 to 24, and we do borders on it. So basically we call borders on... I see. So basically call borders on 0 through 24. So the index, and then we turn an IO direction, and that's put into A. So A is an IO direction. And the reason why direction is an IO is because probably get choice ran stands for get choice random, which we call random RIO right here. And that invokes state, which means this is deity. Okay, so that's some strong ass coffee. Alright, so and let get choice random gets all the valid moves we can make for the index, gets a random RIO, select the direction based on the random index, which is either north or east. So A is a list of directions. So L is a list of blank cells. A equals a list of directions. And then pure fold L, an anonymous function, M, ID, add neighbors, L with MID, L zip 02A. Create an index list of directions, then fold over it, adjusting neighbors to the list of blank cells. So yeah, basically, Now we're applying the 2. Drinking all these liquids was a bad idea. I'll be right back. I have to go to the bathroom, guys. I'll be right back, I promise. Thank you all for waiting. Alright, let's do this. Are you ready? Yes, we are ready. 3 followers in 1 video. Wow, I'm more popular than Active Fireball. Haha. Alright, so now we're kind of adding them together. So we have zip, L, add neighbor, fold L, and pure. So basically, basically the dollar sign is to basically just get rid of the parentheses, because I guess Haskellers don't like parentheses. So we're first going to look at zip. So zip is prelude.zip or data.sequence.zip. This is prelude.zip. Takes a list of A and a list of B. Oh, and just puts them together. Oh, well, that's pretty fucking cool. So zip 0 to whatever on A. I see. All right. Fold L. Fold L. Oh my god. All right. Fold L. Is we take a function that takes B, takes an A, and returns a B. We take a B. We take a foldable of A, and returns a B. So basically, we have a function and a B and an FA and a B. Returns a B. So in this case, the function is this. The B is that and that. So in this case, the function B to A to B is an anonymous function. I, D, and we put into add N, E, I, G, H, B, O, R, L, M, I, and D. B is L, which is the list of blank cells. And then we have F of an A, F of A, which is this. And so zip Zippity-doo-dah, zippity-day. My, oh my, what a wonderful day. Plenty of sunshine coming my way. It's zippity-doo-dah, zippity-day. Is zip 0 through 1a, so this would be a int an a, which is a list of directions, so it's direction. Cool. So don't drop that. Foldable Haskell. And data structures that can be folded. All right, so class of dictionary folded into a summary value. So folding is basically kind of what I just read. Folding is basically you can take a list of something and reduce it to a summary value. And that's the thing, is like when you first learn what folds are, you're like, why the hell would I do this in the first place, right? It's kind of hard. Like Haskell has all of these higher order functions, and you're like, why would I use this higher order function in the first place? So zip is a list, and so a list is foldable. Okay, so now we have this behemoth of a function to worry about. Right? O-U-R. Newmaidumosa. Newmaidumosa. I see you put the O. See you put the U in there. Add neighbor L. So this is an anonymous function, or lambda function. Lambda function Haskell. Anonymous functions. This is a nameless function which increments its parameter x. I see. So a multiple is like this. So basically this anonymous function has two parameters. It has the m, and it has the tuple I and d, which probably I is equal to index and d is equal to direction. Next page. I love writing things down, man. It makes me so much better. Dude, I'm on my what? This, I don't know, what video is this? And I have 3 viewers? Man, I'm doing better than Ecto Fireball. Fuck. Do more programming videos. Alright. So, an anonymous function with m and a tuple of I and d. And we basically say add neighbors. We have m and an I and a d. So add neighbor L. Add NEIGHBOURL takes a cell list and an index and a direction and returns a cell list. So the cell list is M in this case. How do we get M? The index and the direction. What? Hold on. Wait, what? Hold on. Well, I have absolutely no clue what you're doing. I'm here for the support. Yes, thank you, Asmodan. I'm assuming you are here for the support. If you knew what I was doing, I would be quite amazed, since you're like, I'm in beginning in fuckity fuck Python. But to explain what I'm doing, since you weren't here, and I actually never told this to anybody on Sergeant Alpha's Discord. What I'm doing is, so way back when I was unemployed, between being a vendor and being full-time, I wanted to make myself better. So I'm like, I'm going to learn different languages. So I made a maze generator in C#. And here's what the output looks like. Mazes, bin, debug. So if you look at this, right, here is a wonderful maze made by my maze generator algorithm in C#, and I chose C# because that's the language I know the most. So here's the output. Here's another one, which is really cool. So they are different mazes. And this maze was generated using something called the binary algorithm. And so I made the maze generator first in C#, and I'm like, okay, cool. Now, based on this, which is kind of my structure of how I'm going to do it, let's make it in another language. So I chose to do this in Haskell. And I've actually been doing this for quite a while. I don't know katakana on the top of my head, so unfortunately I can't say your name. But thank you for the follow. So what I've been doing is, so now that I did in C#, I'm like, right. Now, Braydor, huh? It's like, so now I've done in C#, now I'm going to do it in Haskell. So, as I was doing this in Haskell, I actually wanted to show people that, yes, you can do things in Haskell. Yes, it's hard, and that's okay. So I started making this YouTube series about me doing this in Haskell. And I've been doing this for about a year so far. And so what I'm doing now is one of my followers who knows Haskell, he's like, I see what you're doing. Let me show you the more Haskell way to do it. Let me show you using high order functions and make it look more like Haskell code and not a hack and slash thing that uses the Haskell syntax. So that's what I'm doing now. I'm going through his example, and he's done it in a really nice Haskell way, and he's great. So now I'm just going through that. That's what I'm doing. So I'm following because I can't just read Haskell code and understand what the hell he means. I can do the C#, Java, C, C++, but not with Haskell since I'm still new to it. Right, we are going add neighbor L. Cell list index direction. So I get where he gets the index. I get this. Where does M? M is just the cell list. So that's L. Oh, I think this gets applied to that. Oh my god. Fold L. Fold L. Takes the function. Oh, so I'm assuming it's applying this to this function. I think that's what it is. L is being applied here, which is the first argument. Then we add this. I and D, a tuple of I and D, which I think comes from here. Yes, I think that's how it works. So I think what's happening is this is M, and I and D are coming from zip. Okay, I think that's what it is. Do an add neighbor, and add neighbor L takes a cell list. Oh my god, more Haskell syntax. Jesus fucking Christ. Oh my god. Whew. This is a workout in just mental exercises. Update a cell in a list to add neighbor, and also updates the neighbor as well, ensuring bidirection. Cell list index direction returns a cell list. Modify L. Modify L. Modify list once with row and column update functions, then update with function that updates current cell neighbor, then updates with function that updates neighbor cell, if vmove is valid, otherwise no updates. Bullshit. Bull fucking shit. Use lens instead of our modify L helper function. Oh, I see. I could use modify L. Or use lenses. Okay, I get it. What is modify L? MODIFYL. Haskell. And so this is what we're going to be a lot of doing. If we do stream tonight, this is what we're going to be doing. A lot of Googling and going, how does this work, and how does this work, and how does this work, and how does this work? modify L. Modify F is an action that updates the state of a result of line F to the current state. No, I didn't. Oh my god. Fine. Fine. Stack GCI. Oh. Really? Alright, then modify L. Takes an L. Oh my god, okay. So we're gonna do this, which is a giant thing. A giant thing. So now we're gonna look at this. So we have L, which is the cell list update. We have I, which is the index to update out. And we have D, direction to add neighbor. Right? So maybe question, I know C++ is a coding language, and from what I can tell, Haskell is as well. Does Python have its own language, or does it code using either C++ or Haskell? So, Python is its own language, Haskell is its own language, C++ is its own language. They are all different languages, but, so, yes, they are all different languages, and they're all different languages for different reasons. C++ is a language that's pretty much bare bone close to the CPU. So there's not a lot of translation between C++ code and code that runs on the CPU. Haskell is a language, but it's called a functional-oriented or functional programming language. And so that is different from C++, which is a procedural or object-oriented. I think it's called a general-purpose language. But Haskell is used for different reasons than C++. Python is higher in the list. So if like the CPU's down here, Python's up here, but basically Python allows you to get more done with less code. However, that is at the expense of there's less stuff that you get to control. So it's a give and take. Python's usually works for a lot of stuff. Python as well is used for a lot of like machine learning algorithms. But that's about it. So there's different languages for different reasons. For example, like there's this language called C, which was a very speedy language. And then Bjorn Stornup, I can't say his name, wanted to add something called classes to C. So he did, and he made it called C with classes, which eventually got called C++. So there are different languages out there that all do different things and are used for different reasons. So yes, Haskell is its own language, Python is its own language, C++ is its own language as well. So, we have L, I, and D. So so we have the dot notation, right? Oh my god. So point-free notation in Haskell is basically making it so we don't have to add as much stuff. So it's very common for functional programs to write functions as compositions of other functions. Never mention the actual arguments they will be applied to. For example, compare sum fold r plus 0 with fold r plus 0 x's. These functions perform the same operation, however the form is more compact and is considered cleaner. This is closely related to function pipelines. It is clear to write let fn equals f dot d dot x, then apply h to x, then g to that, then f to that. So basically, function composition is what these dots are for. And they allow to do function comp. So dots allow us to use function composition. So these dots are basically say do this, and then apply this to that. Why don't I enable streamer mode? Because I never thought about that. What is streamer mode? Is like when I'm streaming, if I'm on Discord, people can also watch me? Is that what streaming mode is? Alright. God, you know, it might just have to be that program guy supporting active file and not the other way around with all these people. Yeah, I remember every time I streamed, when I started streaming, Discord was like, hey, streaming mode is enabled, be careful out there. But, if that does Discord status, I'll have to check, I'll have to read up on that. Thank you for reminding me about that, and I will read more up about that and see what happens. See about it. Alright. So. Fuck a duck. So, as we saw before, the percent sign, percent tilde, is all the way up here. Percent tilde, set. Set with value. And I know I looked this up before. I'm gonna have to get lenses. Lens. I know I had to deal with this before, and I forgot how exactly I need to import it. Lens tutorial. Control.lens tutorial. If so many tabs open. Data.data.lens. Alright, I'll deal with this later. I'll read about how to do this online. Because I know on my laptop I did this, and I was able to get data.lens in here. Oh, import lens? Whatever. So we have the set. So IX is the index to update at. I1 I have no idea, and I have no idea what F2 is. I1, probably the first one, and F2. Where's F coming from? Oh, I get it. Here it is. I1, so F0. Oh my god. There's so much shit here. God, this is going to last forever. I mean, I just might have to start recording more than once a week to get through this. Otherwise, I'm going to be here going through newmaidumosa's tutorials for like another year. Jesus. F0, where X... And then X, you make a row and a divide by width column. Oh, this is record syntax. That's making a point. So F0 is a point, and then F1, F2, and I1 is add neighbor pair. And this is the thing where I've noticed about Haskell is like you can read something and then you go a bit deeper 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 and you go a bit deeper to just it's so much stuff, and I'm going through so much water because of this coffee is so damn strong. I should have made it this strong. Okay. So add neighbor pair. Add neighbor pair takes an index and a direction and returns a tuple, and the tuple is a function and takes another function and an index. All right. So if move ID if not a valid index, then do nothing. if you are a valid index and the direction is north, do this. If the direction is south, do this. If the direction is east, do this. If the direction is west, do this. Cool. So I see an add neighbor pair. So add neighbor pair, what he's doing. Okay, I know what he's doing. This is actually the problem I was encountering before I started reading this. So it's the problem I'm encountering when episode 33 comes out tomorrow at 12:30. So when you're making mazes, right? Let me show you an example. So if I have two cells, right, that are adjacent to each other like this, right? If I'm at this cell and I go make ANEIGHBOR to the right, I'm going to call this circle. Let's just, actually, no. Circle and star. Circle. But also what has to happen is star has to make ANEIGHBOR to the left. Now, this is, I call this bidirectional neighbors. And the reason why you have to do this is because once the maze is made, what you need to do is do a depth first search. Because in order to get that picture that I showed you of the maze, I need to label from this starting location, how many cells is it away from the starting location. And thus I'm going to do a depth first search. But in order to do the depth first search, I have to be able to go back up, so like on a stack. And in order for that stack recursiveness to happen, I need bidirectional neighbors. So this adds the bidirectional neighbor. So that's what it is. So he's saying add an index and a direction. We have, if you're not a valid index, don't do anything. Otherwise, we're gonna have two functions. We're gonna have x. So is has nn is equal to true, has n equals true. Two functions to update the cells, current and neighbor, and index of the neighbor. Okay, so we're doing this is to get the add neighbor pair. So this is to get f1, f2. Okay, I get it. Okay. Oh boy. So again, we have ix. No, come back. So ix is index to update at. I1 comes from here, which is the index of neighbor. And then we have F2, which is the neighbor cell. So this is saying at this index, the index to update at, and the index for a neighbor, F2, using the lens for a modify L helper function. Oh my god. Oh boy, this will be fun. Using lens instead of our modify L helper function. Add and prepare I and D. Return two functions and the index of the neighbor. So I1 is next to neighbor. F1. Oh, you're doing something here. In the case of N, if the direction to move is north, then take X. X has an N. It's a function has an N. Is has an N something here? Find has an N. Oh, has north neighbor. Ha 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 ha. Okay. All right, has north neighbor. So it's basically saying if the direction is north, has north neighbors true, and then has south neighbors true. So he's doing the bi-directional stuff. I get it. Okay, I understand. And X is the index. I see. So at the index, okay, I get it. I get it. So this is just returning functions. Okay, I get it. So what's happening here? I totally understand this finally. So what it is we have ix, which is, yeah, to the neighbor to update at. And so this is saying I1, which is the index of the neighbor, update it on F2, which is the neighbor. So it's saying if the direction is north to update, then we're saying the neighbor, what we have is the has north neighbors true, and then we're going north, and we're having saying has south neighbors true. So this is doing the bi-directional stuff. Awesome. So this is adding the bi-directional. So we have ix I1 update on F2, add bidirectionalness. And then we have ix, this new function, the index to update at, I set f0 dot f1. So I believe we're doing function 1. One quick second, guys. I'm going to mute this. All right, everyone. We are gonna end it here. Because it's been an hour and I have other stuff I need to get done, but I also just said it was gonna be an hour. So you can guys see this episode uploaded to YouTube not this Sunday, but next Sunday. So be on the lookout for that. So what we got done today was we got done. We understood the cell list. We understood that. We looked at fresh cell. Oh, hey, modify L. That's what he's doing. Oh, I could have read that. Okay. We kind of got into add neighbor, and we kind of gotten into the rigmarole of all of this, which has been really fun. So next episode, what you guys can expect is we're going to go through this function and understand this. We understood this, which is the bidirectionalness. And yeah, it'll be fun. So lurkers who are lurking, thanks for lurking. Watchers who are watching, thanks for watching. If you want to see more of me, I do have a gaming channel where I stream every Monday through Friday, 8:30 in the morning to 9:30 in the morning. I will be here next Saturday at 11:30, so be excited for that. I also might stream at some other time because I'm also doing 68K programming as well. But I love you all, and I will see you all next week. Bye.